All right, let's look at section 3.2.3, examples with algebra. So these are examples where the substitution doesn't look like it really works until you can do some algebra and kind of rejig it. All right, so in cases where u is a polynomial, you may need to do a bit of algebra to rewrite the integral in terms of u and to expand this expression to integrate it afterwards. All right, so these are examples where you'll need to you'll need to expand, you might need to isolate, and things like that. All right, so let's look at example 3.2.5, part A. I need to evaluate the integral of x over square root of 1 plus 2x dx. All right, so I have 1 plus 2x. It's in the denominator and in a root. Looking at this, that's my only candidate. The only thing that jumps out at me, so that's what I'm going to take. Then du is 2 dx. And so if I have dx here, I'm going to get 1/2 du. And so this integral is x square root of 1 plus 2x, 1/2 du. The denominator is just root of u. 1/2 du. I need to replace x with a function of u. So this is the relationship I have between x and u. So I'm going to use it to isolate x. So I have u equals 1 plus 2x. That means 2x is u minus 1, which means that x is u minus 1 divided by 2. So here the top is u minus 1 divided by 2. All right, so the integral I have now, let me take all of the 2's outside. They're all in the denominator, so I get 1 over 4 integral of u minus 1. And let me bring the root to the top. It's going to be u to the minus 1/2. 1/2 because of the root, and the minus because it was in the denominator, and I brought it up to the numerator. All right, this is the function I need to integrate, and it looks a lot like the functions that we looked at earlier before we did substitution, where you couldn't split it because it was a product and you had to FOIL. Here we'll just expand, and so we'll get 1 over 4 integral of u to the 1/2 minus u to the minus 1/2. And so we get 1 over 4 u to the 3/2 minus u to the 1/2 plus c. I'm going to multiply the 4 in and replace u by 1 plus 2x. So I get 1 plus 2x to the 3/2 over 6. The 2 cancels one of the 2's from the 4. And then here's root of 1 plus 2x over one of the 2 gets canceled. All right, let's do one more like this. But notice that it wasn't obvious at this point that it was going to work. I knew how to write this part, but I had a part that wasn't clearly in terms of u, but because u was so simple, I was able to solve for x in it. All right, let's try another one. Let's try this integral of x cubed square root of x squared plus 1. So in that case, I'm going to take u to be x squared plus 1. Again, it's inside a root, inside a denominator, inside of another function. These are big clues that you should try them. So I would try this. Now what worries me is I have x cubed outside, but du is going to be in terms of x. So I don't have the right power, and in the past that hasn't worked out well for me. In this case, I had x5, I wanted x5, but I only had x squared, and it turned out that there were extra terms that I couldn't rewrite. And so here we'll get extra terms as well, but hopefully we'll be able to rewrite them in terms of u. Right, so here I have dx is 1 over 2x du. And so if I rewrite this, one of the x's will cancel. So instead of x cubed, I'm going to have just x squared. This one will cancel with 1. And then x squared plus 1 to the 1/2 du. All right, now I need to rewrite all of this in terms of u. The square root, that part is fine. This part is just u, so that's fine. And then x squared, I need to isolate x squared in this. I can't isolate x, and this is part of the reason I did an extra problem. Here, I get x squared is u minus 1, and x would be plus or minus root of u minus 1. It's not a function. I have two different functions here. The plus or minus means that there are two different values for the same value of u, in this case. And so here, I can't isolate x like I could in the last problem, but I can isolate x squared. So x squared is u minus 1. And so here I get 1/2. X squared is u minus 1. And then what's right here? That's u, so it's u to the 1/2. And then when I multiply it in, I get u to the 1/2. I'm going to multiply it in so I can integrate. So 1 plus 1/2, that's going to be 3/2 minus u to the 1/2 du. All right, the rest, pretty basic, just using power rules. All right, so I'm getting 1/2 u to the 5/2 over 5/2. When I multiply it in, the halves will cancel and I get 5. And then u is x squared plus 1 to the 5/2. Same thing, this 2 will cancel with the 2 underneath, and I'll have x squared plus 1 to the 3/2 over 3 plus c. All right, so already you see these are more involved. I have to do some algebra to make this substitution work right here, and then to finish the integral, I have to expand. All right, so you'll see some like this on the next assignment.